Alright, so now we're looking at the data we collected during our test run. If you see here, we already have our accelerometer and our gyroscope here. We're only interested in two of the acceleration dimensions, that being the x and y. So I'm going to unclick the z acceleration data, and then for the gyroscope, we're only interested in the z omega, which is our angular velocity. So I'm going to unclick the x and y. Notice that my data is cut off here, so I'm going to need to refit this edge. I'm going to make this, let's say, minus 30. Your data might be a little different, but I want to see if this fits. And I've gotten the end of my data, and that's the point that I'm interested in. Looking at this data, we see there's a large portion that has a lot of variation. We're only interested in the points between when it was in the air. This is before we threw it. This is the point where it was thrown up. This is the point where it was caught. We're going to look at just the time between where we threw it up and when we caught it. So I'm going to zoom in horizontally on that area by selecting and pulling. And it's zoomed in both on our gyroscope data and our acceleration data. Now we're going to want to do some analysis. So we're going to click on our analysis, and we're going to highlight this area as much as you can. And now we're going to look at our mean values. We see our mean value. Here we have a mean of 7.067 for our acceleration in the x direction, and a mean of minus 16.601 meters per second squared in our y direction. And then we see that our omega has a mean of minus 23.014 radians per second. Now this data is going to give us one point on our graph. But to find the acceleration point, we're going to have to use a vector sum, which incorporates Pythagorean theorem to find our centripetal acceleration. So it's going to be the square of our mean for our acceleration in the x direction plus the square of our mean for acceleration in the y direction, and then we're going to take the square root of that sum, and that's going to give us our centripetal acceleration. That point that we just calculated, along with our mean for our angular velocity, will be used for 1 point in our data. This process must be repeated for each different speed of spinning that you throw the I/O lab up in the air. Each one of those will give us a point in our graph, and we should have at least 3. If you can, try to make a 4th point. It'll improve your data.